Hello viewers, now we are going to see the operation of a non-inverting amplifier using operational amplifier. Here the circuit is having operational amplifier 741 IC, load resistor RL, input resistor RI and feedback resistor RF. It is very simple circuit, and why this name non-inverting amplifier is fixed for this particular circuit is it is producing the positive amplified version of output for the given input. Here the non-inverting terminal is receiving the input Vi, and similarly the inverting input, negative input, is grounded via this Ri. So for non-inverting configuration, the non-inverting terminal must be receive the input and the inverting terminal must be grounded, and output is fed back to this input point node A via this RF. And about the operation, we have to recall the basic input characteristics of operational amplifier. We all know that op-amp's input side or input of operational amplifier draws zero current. I in this input side is 0 amps. This is because of operational amplifier's input side is having very high impedance. So because of the high impedance, the current consumption or current drawn by the operational amplifier at its input side is very less or nearly equal to 0 amps. And because of this, the potential difference between these two terminals, that is a node in the non-inverting terminal which receives the input, is having Vi, the potential, and similarly at node A in the inverting terminal we have to take the potential at the node A as Va. So the difference between these two must be 0. If you take the difference between these two, it means Vd must be Vi. So we must always take reference potential as plus node potential. So Vi minus Va, inverting terminal's potential. This must be 0. So Vd must be 0 because of the current is 0 amps. This current is 0 amps because of op-amp's input side is having very high input impedance. So Vi minus Va must be 0 means both the values of Vi and Va must be equal. Then only you will be having 0 in the other side. So Vi and Va both must be Vi. Then only Vi minus Va you will be having 0 volt. So by this way, the potential in this one arm, that is plus arm, will be also available in the minus arm. So Va will be named hereafter as Vi. So Vi minus Vi, difference between these two will be 0 because of I equal to 0 amps. So node A potential, initially it is named as Va, but now it is Vi. That is exactly same as that of the potential available in the non-inverting terminal. That is our actual input. And to find the output, we have to consider these two currents. Ii, because of grounded, Ii's direction is reverses and it comes out of node A towards ground. And the feedback current If, that connects the output V out to this node A, that is Vi, via this RF. So if you apply Kirchoff's current law at this node A, means Kirchoff current law is KCL at A gives sum of the current entering the node. First current is If entering the node equals to, only one current is entering the node, equals to sum of the current leaving the node. Current leaving the node. Here from this node A to ground, Ia is leaving the node A. So Ii plus one more current is moving towards this op-amp. Since op-amp's input side draws 0 current, so the current moving towards op-amp is taken as I, that is 0 amps plus I. We have to name this as equation 1, and we know that this I is always 0 amps, so don't consider this for analysis. So finally we have IF equals to IA, that is IF is the feedback current and IA is the input current. And to find these current individually we have to use Ohm's law and by considering the nodes. To find IF, source node potential minus destination node potential divided by the component. V out minus destination node potential is VI. VI by the component RF will give you IF. So by using this you can find IF. Similarly for II, here source node is A because current is coming from node A to ground. So source node potential is the node A potential, that is VI, minus destination node potential is grounded, so 0 volt, divided by RI will give you this II. We can write II equals to source node potential VI minus destination node potential 0 volt because it is grounded, divided by RI. So by using these two, we'll be able to find the current equation and to solve it for output voltage of non-inverting amplifier. As we discussed earlier, KCL at node A gives IF feedback current equals to input current plus IB minus here. In the diagram we have mentioned this as I. This will be 0 amps. So you won't consider this for analysis. So IF equals to II. Since I or IB minus at input of op amp is 0 amps because of its high input impedance. So after that IF is V out, output potential, minus node A potential by the component RF equals to node A potential minus 0 grounded by RI. Here node A potential is VI, so V out minus VI by RF. This is for IF, and VI minus 0 by RI, it is simply VI by RI. This is for II. This we have already discussed in the diagram. So after that V out by RF equals to, you move that minus VI by RF to the right hand side, makes it VI by RI plus VI by RF. So V out by RF equals to take VI outside, 1 by RI plus 1 by RF. You take common multiples, V out by RF equal to VI into 1 by RI plus 1 by RF. Here V out equals to VI into, you move that V out to the right hand side, 1 by RI plus 1 by RF into RF. So V out equal to VI into, you multiply with RF means RF by RI plus RF by RF, it is 1. 1 plus RF by RI you will be having. So V out equals to 1 plus RF by RI into VI. So finally, you bring this VI to the left hand side, it is V out by VI equals to 1 plus RF by RI. So V out by VI is always output potential by input potential is always gain of non-inverting amplifier, that's why ANI equals to 1 plus RF by RI. And if you consider the output, V out equals to 1 plus RF by RI into VI. So if you give VI is 1 volt means, and if you choose RF is 10 kilo ohm and RI is 1 kilo ohm, as we discussed in the inverting amplifier, means it will be 1 plus 10 kilo ohm by 1 kilo ohm is 10, 1 plus 10 is 11, 11 into 1 volt you will be having 11 volt. So V out equals to 11 volt for the input of 1 volt. So if you choose input is 1 volt for this particular non-inverting amplifier, and with the value of gain value of RF by RI ratio is 10, means you'll be able to get 11 times amplified version. For the same input and same RF and RI configuration in inverting amplifier, you'll be able to get 10 volts and minus 10 volts. In fact, because of inverting operation, you'll be able to amplify it to 10, but with the minus 180 degree out of phase output you will be able to get. But here, for the same input and same feedback and input resistor value, you'll be able to get 11 times amplified version of the input. So output is 11 times amplified. So you'll be having better amplification in this configuration, and these kind of configurations are also utilized in many operational amplifier applications. If you want to test an example and draw the input and output waveforms for this non-inverting amplifier, means we can choose Vi given to the circuit is 1 volt sine wave. So we are planning to give sine wave with an amplitude of 1 volt, and we know that the output of non-inverting amplifier is 1 plus RF by RI into Vi. So here 1 plus RF, if you choose RF equals to 10 kilo ohm. 10 kilo ohm divided by Ri is 1 kilo ohm means into 1 volt sine wave. So this kilo ohm is cancelled. 10 by 1 is 10. So 1 plus 10 into 1 volt will be having 11 volts. So for 1 volt sine wave input, you will be able to get 11 volt sine wave. And the main important thing in this is it is plus. The potential's nature is positive. So you have to draw waveform for 1 volt sine wave input and 11 volt sine wave output. So V out equals to 11 times amplified version of the input. So here input potential is considered as having 1 volt. So with respect to this 0 plus 0.5 volt in above the 0 line and minus 0.5 volt below the 0 line. This is 0 line. So this is minus 0.5. So plus 0.5 to minus 0.5, peak to peak value will become 1. So this is your input potential. Name this as Vi. And for this 1 volt, you will be able to get 11 volt potential. So in the positive side, you have to choose 5.5 volt plus with respect to 0. And in the minus side, you have to choose minus 5.5 volt. So totally peak to peak value becomes 5.5 minus of minus 5.5, totally 5.5 plus 5.5, so 11 volts. So here the potential is positive, so we have to draw the waveform without any phase shift with the input waveform. So you have to draw like this. So here the waveform is drawn between plus 5.5 volts to minus 5.5 volt, and you can name this as your V out. And if you consider the phase, means here it is having 0 phase shift with input. The output is having 0 phase shift with input, whereas in inverting amplifier, because of the minus in the result, so we have to draw reverse 180 degree out of phase with the input. Now there is no phase shift between the input and output, and the time period here it is 5, 2 pi and 3 pi. Similarly here also will be having 5, 2 pi and 3 pi. The same time period you will be having amplified version. For 1 volt input, Vi of 1 volt, you will be having V out of 11 volts. Thank you.